Hello students, I welcome you all to Conadena classes. In this video, we're going to talk about a question based on pseudo force. So let us see what is the question. The question is a man 80 kg. He stands on a weighing machine in a lift that is moving upward with a uniform acceleration of 5 meter per second square. What would be the reading of the machine when the person is in the lift and the lift is going up? See, one thing like so far we have seen one thing that if you talk about the non-inertial frame of reference, means if you talk about the frame of reference which is accelerating with some acceleration, right? In that case, what is happening? The person who is inside the lift, with respect to that observer, we have to apply pseudo force. But with respect to a person who is standing on the ground, we are not going to apply pseudo force. We have the general laws of motion that is valid in case of the observer who is standing on the road, but laws of motion is not applicable when the person is in accelerated frame of reference or non-inertial frame of reference. In that case, just to make the laws of motion valid, what we have done, what we have to do, we have to apply the pseudo force, right? So in this question, what is happening? This person is inside the lift and lift is going up with some acceleration that is mentioned here. That acceleration is basically, that acceleration is 5 meter per second square. So this is 5 meter per second square. That is, with this much acceleration, the lift is going up. So now what is happening? If you talk about the observer who is inside the lift, right? So the equation that I'm going to write right now is with respect to a person who is inside the lift. Okay, let us do one thing. Let us solve this question with the two method and let us see that we are getting same answer or not. So consider this is the observer 1. This is observer 1 and there is one more observer at the ground level. If you talk about the observer 1, with respect to that observer, what is happening? The person is at the rest with respect to that person, with respect to that observer actually. So what is happening? This is suppose the man having mass 80 kg, so that guy will apply the very first force, that is mg, and g we have to take 10. So 80 into 10 is 800 newton, we have to take downward, and that guy will tell us that okay fine, this is the normal reaction, right? But since this lift is going up with some acceleration, that guy will apply pseudo force also, and that is opposite to the acceleration of frame of reference. So lift is going up, so then in that particular case, the pseudo force will act down, and that is going to be mass of the person times acceleration of the lift. So that is plus 80 into 5, right? So with respect to a person who is inside the lift, that is the first observer, with respect to that guy, if you talk about the equation, we will say that okay, normal reaction is going to be 800 plus 400, that is actually 1200. And weighing machine is doing nothing. Weighing machine is just going to measure the normal reaction, right? So the reading of the machine is going to be 1200 newton with respect to an observer who is sitting inside the lift only, right? So the option should be D. Now let us talk about the other method. Let us talk about the observer 2. Now this observer is standing on the ground, right? So this observer will tell us that okay fine, if this is the man having weight 800 newton, this is going up, so the normal reaction will be up. But that guy, this guy, like observer 2 will tell us that if the entire lift is going up with some acceleration that is 5 meter per second square, this guy is also moving with the same acceleration upward. So according to the observer 2, this is going up with the acceleration 5 meter per second square, right? So if you talk about the equations that will be written by the observer 2, that guy will tell us normal reaction is up and acceleration is up, so net force has to be up. That means the normal reaction is up, that minus of 800, that is the weight of the object, that has to equal to mass times acceleration. So mass is basically 80 kg and acceleration is 5 meter per second square upward. So that into 5. So this is n is equal to 800 plus 400. So this guy will also tell us that the reading is going to be 1200 Newton only, right? So you can just see here it whether you talk about with respect to a person who is sitting inside the lift, right? That is in the non-inertial frame of reference, or if you talk about a person who is standing on the ground on the inertial frame of reference, both the guy will tell you the same thing, that the reading of the weighing machine is just 1200 Newton, right? I hope this question is clear to you. Thank you.